Hello everyone, today we will discuss two stack push down automata. In last 3-4 lecture we have seen using one stack push down automata, like that context free language is given. For that we have designed the deterministic push down automata, non-deterministic push down automata. For that only we use one stack is there. So what is two stack machine? Why we required? If any language is not context free, it is go to higher like a context sensitive language, that can be. For that if we will use the stack, then we need here two stack. We need here two stack to design the push down automata. So here suppose here see what is the two stack push down automata tuples. So two stack push down automata is exactly like a push down automata, except that it has two stack. In normal push down automata we have only one stack. For that we design the context free language to push down automata, and context free grammar to push down automata, and also there is a DCPL to deterministic push down automata, there is a non-deterministic push down automata. For that we use only one stack. So here if suppose some language is go to the higher language in Chomsky hierarchy, we have seen like that in context free, this is a context free language, regular language, then after context free language, then after context sensitive language. For this context sensitive language we can design that using two stack PDA for some context free language, context sensitive language. So here this two stack is more powerful than one stack PDA, because we are using two stack. So that's why it is the more powerful than one stack PDA. And here is the tuples are like that capital Q, it is same thing. Say capital Q, this is the set of states, and sigma input alphabet, set of input alphabet, and tau is the stack symbol, z is the stack bottom, del is the transition function, and q0 is the initial state, f is the final state. But here transition function is some little bit different from the one stack push down automata. What was the one stack push down automata? In one stack push down automata transition was one stack push down automata transition, one stack, this is the q and this is input alphabet and this is tau, and here we are going to like that what is the in one stack, it is in one stack it is like this. So it is q p q and this is stack. So this is the, you know that p means this is a power set, p means this is a power set, this will be power set, means maybe this is for non-deterministic, many number of state will be there. So here one stack q input alphabet tau, here is the only single stack in one stack. But here we are taking two stack, input alphabet is same, input alphabet, and this is stack 1, and this is stack 2. So here we are using two stack, and here also after operation this is the stack 1, this is stack 1, and this is stack 2, this is stack 2, stack 1, stack 2, this is the stack 1, stack 2. So simultaneously you have to give some operation in stack 1 and stack 2. For a single input you read some input and you have two stack, you maybe do operation in one stack, another will be no operation, like that push pop, like that you can see both stack you can do some operation, push pop, no operation. So see here what are the example here, one example here you see here what is the diagram you can say, this is the stack 1, this is the stack 2, and this is the input tape, and tape head finite control head moves from left to right. So both stack are connected to this finite state control, and a single input alphabet you have to read, and both stack you have to make it some operations. So here some examples are here. You see here we have taken here, this is, you know that this is the input alphabet, and this is the stack 1, this is the stack 1, and this is stack 2, this is stack 2, and this is after processing, this is stack 1, and this is stack 2, this is stack 2. So this the transition, you see we have taken one transition, example transition. Suppose input alphabet is A and both the stack having Z, Z is the stack bottom, Z is the stack bottom, Z is the stack bottom in both the stack 1 and stack 2. So what we do here, Q, when you read the input alphabet A, stack 1 is no operation, and stack 2 we push A into the stack, stack 2 we push A into the stack. So this is no operation, no operation, no operation, and this is push A, push A, push A. So here we no operation in stack 1 and push A into the stack 2, A into the stack 2. So this is a transition given Q, A, Z, Z. So P, when you are in Q state and read input A, and you have two stack 1 and stack 2 both having Z stack bottom, then Z, what you have to do, in stack 1 you no need to do anything, there will be no operation, and in stack 2 you have to push A into the stack. So this transition is given that here no operation in stack 1 and push A into the stack 2. Okay. So now go to the second transition. I have taken an example here, you check it, this is Q, A, and here stack top is stack 1 having A, stack 2 having Z. You see stack 1 having A and stack 2 having Z. So after this, when it is going to P, then this one is stack 1. In stack 1 you have to pop, and stack 2 you have to push A. So you read A input, what we are doing here, in A you read input is A and stack 1 top is A, then we pop A from the stack, pop operation in stack, here pop operation in stack 1 and push operation, push A into the stack 2. So whatever top of the stack in top of the top symbol in stack 1, that will be pop, and whatever input alphabet will be pushed into the stack. So these are the example transition we have taken. So here is the, you see it, this is pop and push, but this pop push are in different stack, these are stack 1 and stack 2. For a single input alphabet we can do push operation, pop operation, like that, any operation, no operation, but this should be a different stack. Okay. So we will take an example which language should be accepted, for which type of language we need 2 stack push down automata, we need 2 stack push down automata. So let us check an example, A to the power n, B to the power n, C to the power n, n greater than equal to 1, and design a 2 stack PDM. So for this we cannot have 1 stack PDM. What are the strings here? Strings are here, strings are A, suppose we will take the example A, B, B, C if n equal to 2. For this, if you will use your 1 stack, so 1 stack what you have to do? You have to push A, Z, A, then for each B you have to pop A, pop A. So for this we can compare A, B, but we could not compare C is equal to A or B. This should be equal number of A, equal number of B and equal number C. We compare using one stack, we can compare number of A and number of B is equal, but C could not, because already we push A and for each B we pop A from the stack and compare A, B, but when we will go to C, stack is empty, we don't have any information. That's why we could not compare this one to C to AB. That's why here we need two stack PDF. We need here two stack we need. Suppose we have taken here Z1, Z2, here two stack 1 and stack 2. So here we have to take stack 1 and stack 2. Let us write the transition function. What would be the transition function? What is the diagram will be there? Then after we have to see one example, the string, how the string is accepted by this push down automata. Let us do the diagram. You can do the write the transition form, you can write the diagram form, anything you want can do. Suppose now you see what you have to do. First A is the input and this is Z and this is Z and this is AZ and this is Z. Are you getting this? This one is saying that your stack top is both stack is empty, means stack bottom, and A will, when you read A, push A into the stack 1 and Z another stack 2, you have to no operation. So now you, if it is same thing, you write here A, Z, then this is A, Z. In this, what do you see? If your stack input is A, stack 1 contain A, then A will be pushed into the stack 1 and Z in stack 2, no operation. So now if B is coming input, then what you have to do? B is coming, so here B input is B, stack top is A, stack 1 top is A and stack 2 top is Z, then what you have to do? This is epsilon and BZ. So this is Q1. So Q1 you have to make a loop, same transition. What you have to do? B, this is A, this is Z and here is the epsilon BZ, BB. So this is B, this is B, this is B. Already we have taken B into the stack, already we have taken B into the stack, already we have taken B into the stack. So this is B into the stack, so BB, epsilon BB. So now see what let me complete, then after that it is C, input is C and this is Z and this is B, then this is Z and this is epsilon. So now Q2, this is same, you have to write, this is C and Z, this is B and this is Z, epsilon. So now this is epsilon Z go to QF, this is accepted state. So here you can see this Q0, you see already you know that here Q0 A Z means here this is the stack 1, again I am writing this is the stack 1, this is the transition is Q0 and this is the input, this is A and this is Z and this is Z. This is input, and this is stack 1, and this is stack 2. So, here what we did in Q0, all A push into the stack 1, and in stack 2 there will be no operation. When we will change the state, what you have to do, in stack 1 you have to pop A each B in your stack 1, you have to, this is pop, and this is push. So, read B and pop A from the stack 1 and push B into the stack 2. So, similarly here in Q1 there is a loop. In Q1 you read B and input stack 1 input is A and stack 2 input is B, stack 2 top is B. Then what you have to do, from stack 1 you pop A and in stack 2 you push B. So, here is, then after when C Q1 to Q2 you have to read C input, and here already stack 1 is empty, because whatever number of A and each B we pop A from the stack 1. That is why stack 1 is Z, So, stack 2 remaining number of B's. So, each C, when you read C and you have to pop 1 B from the stack 2, so that it will be all equal number of A, equal number of B, equal number of C will be accepted. So, take an example here, we will take a small example how this is accepted. You can have, suppose we will start here Q0 and input is A, B, C, and this is Z and Z. This is stack 1, stack 2. So, this is stack 1, first one is stack 1 and second one is stack 2. You see Q0 A, what you have to do? This is Q0, then A will be pushed into the stack 1, and second stack is empty. Then after you see again A will be pushed into the stack 1. Now, B, C, this is A, Z and Z. So, now Q0 input is B, stacked up is A, first one stacked up is A, second one second stack stop is Z. So, what you have to do, go to Q1 and B, C, A, Z, BZ. Okay, because we have to pop and then push, in stack. Then after you see Q1 input is B, stacked up is A, input is B and stacked up is A in stack 1 and B in stack 2. Input is B and stacked 1 top is A, stack 2 top is B. So, what you have to do? Pop B from the stack 1. Now, Q1 C and this is A, Z and this is B, Z. This is B, Z. So, now you see this is B, Z. Okay, now you see Q1 C, Z, B. Now you see in Q1 input is C, stack 1 top is Z, and stack 2 top is B. So, what you have to do? Go to Q2 and pop B from the stack 2, and whatever stack 1 that is remains same, that will be no operation. So, here it will be Q2 and C and this is BZ, this is Z, Q2 C Z stack 1 remain no operation, this will be Z and stack 2 will be BZ, stack 2 will be BZ, stack 2 BZ, stack 2 this is Z and this is BZ. So now in Q2 CZ BZ, you see here CZ stack 1 is Z, stack 2 is B, input is A, input is A. So here this is Q2 epsilon Z Z, this is Q2. Now this is QF. So this is the accepted. So here the transition function we have written, you check it again, and this is the stack 1. What we are doing, again I am explaining this Q0, first one here 3 you have written A Z, then after that this A Z. This means here we are, first one is input, this is first one is input, second one is the stack 1 and this is the stack 2, stack 2. So like that here each operation you can write like this in a transition. I am writing the in transition, whatever I have given the diagram, let me write one transition like explain. So you see here Q0 A and this is Z and this is Z. So this one equal to Q0 AZ and this is Z. So this is the transition function in Q0, Q0, then Q0 A and this is A and this is Z. So this is Q0 A Z. So these are the transition. Again I am writing here Q1, if Q0 input is B, stack 1 top is A, stack 1 top is A and this is Z, what you have to do, Q1 and this is epsilon, this is epsilon and this is BZ. You can see this one is input, this is the first, this is input, this one is input, this symbol is stack 1, this one is stack 2 and here also this is stack 1, operation on stack 1 and this is operation on stack 2, operation on stack 2. So each transition should be like this in push 2 stack push down automata. So we have same input is same, a single input, but we have 2 stack is there. So as per your requirement we can do push, pop, no operation like this. For here what you do, in Q0 we push all A into the stack 1, into the stack 1, whatever A will be pushed into the stack 1, then make it second stack as a no operation, make it second stack as a no operation. Then when you read the input B, when you will get the input B, then we move it to the Q1, then you pop 1A from the stack 1, again B will be pushed into the stack 2. So you are in Q1. Now in Q1 again you get input is B, stack top is A, stack 1 top is A and stack 2 top is B, though what you have to do, you push A from the stack 1, push B into the stack 2, like that. Whatever A in Q1 state itself, stack 1 will be empty, stack 1 will be empty in Q1 state itself. Then after we will get here C, already number of B push into the stack 2. So when we will get here input as a C, and in Q1 state input as a C, stack top as a Z, stack 1 top as a Z, because it is already empty, and stack 2 is B. So what you have to do, make it no operation in stack 1 and pop operation in stack 2. So like that you are in Q2. So same thing, C Z B and Z epsilon. So in Q2 that will be all stack 2 will be empty. So already stack 1 was empty in Q1 and Q2 stack 2 is empty. Then we will go to the final state. We have read all the input and all 2 stack is empty. So we have to go to the final state. We have to go to the final state. So this is the about the 2 stack push down automata, and this 2 stack push down automata we can, whatever this context free language, we can use the 1 stack push down automata, but this if any language is higher than context free language, like the context sensitive language, this language is 2 comparison. A comparison at a time, A comparison with B and A compare with C. So for this, this is a context sensitive language. For this we have to use 2 stack push down automata, and it is equivalent to Turing machine. Also you can say this is the linear bound automata. So like that, if any context sensitive language is given, so we can use to design push down automata, but we have to use here 2 stack. So today about all this about this. So these are the reference book, and thank you.